Okay, so this is a harder problem. This is ammonium phosphate. We've learned a lot about naming these things and writing the formulas, and here's why it's so important to be able to interpret the formulas. This 3 that is here applies to everything backwards in the parentheses. So there are 3 tables, if you will. There is 1 tabletop and 4 table legs, but there are 3 sets of tables. So again, there's 3 of the ends, and there's a total of 12 of the H's. Okay, the PO4, there's only 1 of the P because there's no subscript here, and there are 4 O's working backwards. Remember, the subscripts apply to the thing before it. So when we set up the math for this, it's going to look a little bit different just because you have to consider all of everything that is present. So we would wind up with 3 ends, 12 H's, because 3 times 4 is 12. There's only 1 phosphorus, and then there are 4 of the oxygens. Now, by the time you do this a bunch of times, you're going to start to memorize some of these numbers. But in the meantime, make sure that you always look them up to make sure that you know exactly what they are. So in terms of the ends on the periodic table, the end number is 14.01. We already did the H number in the last problem, but it's 1.008. And I'll make those dots just a little bit bigger for you guys at home. And then phosphorus. If I look carefully there, it's 30.97. And then for oxygen, it's 16. Then we're going to multiply all of these out with our calculator and add them up. You definitely want to do this step by step. You do not want to get into the habit of putting it all in your calculator in one step, because then if you make any mistakes, it'll mess up your whole calculation. So you have 3 times 14.01, and that is 42.03. 12 times 1.008. That's going to be equal to 12.093. 1 times 30. We can just keep that number the same without doing any crazy math. And then 4 times 16, many of you may know that that's 64. And so we're going to add all of those numbers up, and we wind up with 42.03 plus 12.093 plus 30.97 plus 64, and you're going to wind up with 149.093. And remember, our conversion factor for A, that's this one, molar mass, is always going to be blank grams of X. We change X over to the substance, is equal to 1 mole of X. So we have blank grams of X, which is this NH4 parentheses 3 PO4, is equal to 1 mole of, and of course I'm running out of room again, so I'll do it a little bit further down, NH4 3 PO4. And so that is how you find your conversion factor for path A, which what we call our molar mass. Okay. All right. I think that is just about it in terms of how to find that number. And our very next lesson will be on how to use that conversion factor. Alrighty then.